So let's continue. This is part two of the Newton-Raphson load flow for a three-bus system. So part one video I have already done, in which we have written down the three functions and we have written down the general form of Jacobian matrix. So one mistake while I was having water and then I was cross-checking, so I forgot to mention minus P3 here. So let's quickly correct that. So minus P3. And then in this also I have to mention minus q2. So total there will be four terms. So now I have these three equations and then I have to define this Jacobian function. So in this video let's start doing that. So very quickly let me open a new page. Let me just adjust it once a new page opens.
It's 1 o'clock.
Okay. So what I'll do is I'll take one by one each equation and then I'll do that. So let me take the first equation. So I copy this equation and then I go to this new page. So I have the first equation ready on my screen. So let's differentiate it. So the elements of the Jacobian matrix will be J11, J12 as I mentioned before. So see here in this video, sorry. So the first element of the Jacobian matrix is this one. Differentiation with respect to delta 2. So let's do that. So differentiation of the above function fp2 with respect to delta 2. So this is my j11. So delta 2 is here. So cos of delta 2 will be minus sine. Cos of differentiation from cos is minus sine, but then because minus is there, it will become plus. So if this term will be as it is. So we just cos replace with sine. So I'll get y21 v1 v2 sine theta 21 plus delta 1 minus delta 2. So how the first term is differentiated, cos will become minus sine, but then because there is a minus of delta 2, the minus gets cancelled. Now the second term, if I differentiate with respect to delta 2, there is nothing, no delta 2 here, so that will be 0. So I'm not writing that 0. The third term, if you differentiate with respect to delta 2, the same story repeats. Cos will become sine and the minus will cancel that minus. So I'll get plus y23 v3 v2 sine theta 23 plus delta 3 minus delta 2. Now differentiation of P2 is 0 because P2 is constant. So this one element I have completed. So this is nothing but J11. Now how to get the J12? That is the first row second element. So if I once again refer to my Jacobian matrix, so I have to differentiate the function same P2 with delta 3 variable. So let's do that now. So now I want to differentiate this function, the first function, with delta 3 as a variable. So in the first term there is no delta 3. So differentiation of function P2 with respect to delta 3. In the second there is no delta 3. In the third there is delta 3 here. The differentiation of cos is minus sine. And since the delta 3 is already plus, so I don't get another minus there. So therefore the minus will remain. So I'll get like this: minus y23 v3 v2 sine of theta 23 plus delta 3 minus delta 2. Similarly, this is all the other terms does not have anything. So that's all. This is J12. Now let me get J13. So what is J13? This is differentiation. So if I refer to this, so the differentiation of function with respect to variable v2. So So look at this entire thing. Wherever you find v2, all the three terms have v2. So we'll get like that. Differentiation of function p2 with variable v2. So let's take the first function. So v2 is only once, it is to the power of 1. So I'll just write this without v2. So y21 v1, v2 will not come. So cos of theta 21 plus delta 1 minus delta 2. So this is done. Now in the second one I have v2 square. So v2 square differentiation is 2 into y22 into v2. So and then cos theta 22 I have. And the third term, I have only one v2, so I'll just write everything without v2. So plus y23 v3 without v2. So cos of theta 23 plus delta 3 minus delta 2. And finally, the p2 is a constant, so differentiation is 0. So I'm not writing it. So that's it. So I found the three elements of the J matrix. So let me, I don't want them to run away anywhere, so I'll just put a box around them. This is the first row of my Jacobian matrix. Now let's do the second row of Jacobian matrix. So in order to do the second row of Jacobian matrix, I will copy the second equation. So I'll go up. So this is the second equation. So I'll just copy this. So copy and then I'll paste it here. So now calculation of row 2 of J. So let's do that now. So J21. So differentiation of function with first variable delta 2 and J22 is differentiation of the the second function, I think p3, with respect to the second variable delta 3, and finally J23 is differentiation of the function p3 with v2. So let's do that. So let's look at differentiation of this function with delta 2. So if I go back to my map, so I'm doing this one now. Differentiation of function p3 with delta 2. So let's do that here. So delta 2 is not in this term, so forget it. Delta 2 is here. So cos differentiation is sine with minus sign. So that's what I'll get it. Minus y32 v2 v3 sine theta 32 plus delta 2 minus delta 3. So again there is no delta 2 here. So I am done with this. Now let's do the second J22 term. Differentiate this with delta 3. So delta 3 is in first and second terms. So I'll get two terms here. So cos with a minus delta 3. So this will become sine, and because of this minus, the minus will cancel out. So the differentiation, I'll get y31 v1 v3 sine of theta 31 plus delta 1 minus delta 3. So just the cos will become sine, and the second term also plus y32 v2 v3, and then I'll have sine and then delta 32 plus delta 2 minus delta 3. Now the last one does not have delta 3, so this is 0 and this is also 0, the differentiation. Now let's do the final one. Differentiate with respect to v2. So we have done this. Now differentiation of the function with respect to v2 we have to do. So let's do that. Now there is no v2 in the first term, so leave it. There is a v2 in the second term, so I get everything except v2. So let me write that y32 v3 without v2 cos of theta 32 plus delta 2 minus delta 3. So this is complete. Now there is no v2 in this, and there's no v2 in this. So that's it. So these are my the second row elements of the Jacobian matrix. So again, let me put a box around them so that they don't run away somewhere. So as I said, everyone in life should do once this writing down these equations so that you understand what is going on. Now go up. This was row 2. So let's do calculation of row 3. So for that, I'll copy my third equation. And then I'll paste it here. So this is row 3. Then the first element of Jacobian in the row 3 is this one now. So the function is q2 and I differentiate with delta 2. Sorry. So differentiation of function q2 with respect to delta 2. So where is delta 2 here? So here is a delta 2 and there is no delta 2 here, and here is a delta 2. So two terms I'll get it. Differentiation of sign is cos. But because there's a minus sign here, that minus sign will cancel out this minus sign. So I get to say everything without minus sign and sign replaced with cos. So for this term and the last term. So let me write it here. Let me use a more brighter color. y21 v1 v2 cos of theta 21 plus delta 1 minus delta 2. So this is the first term. Then here there is no delta 2, so the differentiation of this is 0. Differentiation of q2 is also 0. And the differentiation with respect to delta 2 will be plus y23 v3 v2 cos of theta 23 plus delta 3 minus delta 2. So this is the first element I have written down. Now what is the next element of the Jacobian matrix? This is the next element of the Jacobian matrix, differentiation of q2 with delta 3. So let's do that. Differentiation of function q2 with respect to delta 3. So where is delta 3? There is no delta 3 here, there is no delta 3 here, there is a delta 3 here. Differentiation of sign is cos, but because delta 3 is positive, I don't cancel out this minus sign, so I'll get minus y23 v3 v2 cos of theta 23 plus delta 3 minus delta 2. So this is also done. Now the last row will be differentiation of function q2 with the third unknown variable v2. So let's stick that here like this. So let's do that. Differentiate this with v2. So I have v2 here, v2 square here, and v2 here. So let's take the first equation. So I'll get everything except v2. So minus y21 v1 without v2 sine 21 plus delta 1 minus delta 2. This is the first term in the summation. Here v2 square is there, so it will become 2v2 after differentiation. So it will become minus 2 y22 v2 sine of theta 22. So this is 1. Then the differentiation of q2 is 0 because it's a constant. And the differentiation here with respect to v2, I'll get everything except v2. So minus y23 v3, v2 will not come, sine of theta 23 plus delta 3 minus delta 2. That's it. So there's it. We have done the complete exercise of writing down each element of the Jacobian matrix. So this is the third row of the Jacobian matrix. So I'll directly type it in the MATLAB equations. So this is third row. So this is J31, J32, and this is J33. And if I go up, this is J21. Let me not confuse here. Already I have written, and then this is J11, J12, and J13. So I have all the 9 elements of the Jacobian matrix, and I have the 3 functions also. So I have 3 functions and 9 elements. This is what I have to program in my MATLAB function. And once I have that, then it's just a matter of calculating the unknowns. So what are my unknowns? Delta 2 is an unknown, delta 3 is an unknown, and V2 is an unknown. This is n plus 1 equal to delta 2, delta 3, delta V2. This is the previous values after the nth iteration minus I'll get the function P2, function of Q2, function of V2. Sorry, P3 and function of Q2. All the function values I'll put it as a column matrix and then divide it by Jacobian matrix. So 1 by Jacobian is J inverse actually. So or I can put it here with a minus sign. So this is my Newton-Raphson method. So hopefully I have not done any mistake in the writing down the equations. So let me check the equations once again, and then in the next video I will open MATLAB and then I'll start typing these equations, and then we'll try to solve the load flow using the values that we have assumed before, and then try to find out the delta 2, delta 3, V2 values. So thanks for patiently watching this video, and I hope everyone tries this out yourself. Switch off this video and then take a sheet of paper and pencil, and then write down all these equations. I said pencil because you also need eraser, because you will be doing a lot of mistakes like I do. Thank you.